All right, on this set of notes, we're going to investigate our new form of a parabola, and we're going to start talking about the definition of a parabola. So the first thing that I want to touch on is these forms that we've already studied in our past, okay? You would have studied these in Algebra 1. You would have done your deepest studying of them when you were in Algebra 2, okay? This first one, you typically, in your earlier math career, would have called this one standard form, okay? In our standard form, our most useful thing for it was that it allowed us to identify the y-intercept. On our next one, you would have called this intercept form in the past because it allowed you to quickly identify the intercepts of the graph, the x-intercepts. And our last one is most often referred to as vertex form because it allows us to identify our vertex. Now, some of these names can be switched around and they're often referred to as different things, but these are the most common names for these forms. So looking down here at the bottom, what I want you to notice is that I've given you the equation for a quadratic, for a parabola in vertex form, okay? Not only did I give this to you in vertex form, I've actually given you the graph. So working with our vertex form, we can identify, of course, our vertex. And in our past, we would have identified that as a 2, -5. Okay? And we can come over here and see that, oh yes, that is in fact our vertex. We also could have identified and would have identified our axis of symmetry as x equals 2. Remember, the axis of symmetry is always a line. It is always a line that divides our parabola symmetrically, passing through our vertex. So what we want to do is we want to take this equation, knowing that it applies to this graph, we want to transform it to our new form and see how that new form can be useful for us. So what we need to ultimately do is get the x minus h squared on one side and everything else on the other. So we're going to rewrite this equation. Y equals our 1/4, x minus 2 squared minus 5. First thing we're going to do is we're going to just move that 5 to the other side. And as you learned in your previous notes, and what we can see up here is that this coefficient and this exponent have to be on different sides of the equation. So although this is close to this form, we're not quite there. We're going to get rid of that 1/4 and we're going to write it as 4y plus 5. We're not going to distribute it, x minus 2 quantity squared. This would be the final answer in our new form. So now what we want to know is, how is this new form even useful for us? Well, what we can see up above is that our new form introduces a new variable. And what that tells us is that this coefficient is equal to 4p. So we can take 4p and set it equal to 4 and solve for this p-value. That p-value is going to be useful for us. So now, looking down here, what does our p-value equal? It's 1. And what does it mean for our graph? Well, the p-value allows us to introduce these two new vocabulary words that will connect to our definition. The focus is going to be a point inside the parabola, and it's going to be p units from the vertex, okay? And it specifically needs to be on the axis of symmetry. So drawing in our axis of symmetry earlier was very useful. So I can put a dot there, 1 unit. I'm going to put an F there for my focus. My directrix is going to be a line that's perpendicular to the axis of symmetry. It's also going to be p units from the vertex, and it's going to be outside the parabola. So I can go p units away, and then I can draw in now a horizontal line. Okay, so there's our directrix. Now, remember, if we need to actually identify the focus and identify the directrix, okay, if I want to, since the focus is a point, I need to write that point as an ordered pair. In this case, I can read it from my graph. As we move into the notes, we'll learn how to do it without needing a graph specifically. And our directrix is, of course, going to be a horizontal line, so it's going to be a y equals, and I can see that it's at -6. So those are important. The last thing that we can do is we can take this focus and directrix and then talk about our definition for a parabola. The definition for a parabola is a set of points that are equidistant from both the focus and the directrix. So from both the focus and the directrix. Now, that's sometimes a little bit confusing of a definition for people. So let's take a look and see what that really means. So it's going to be a set of points that are equidistant. Okay, so this parabola here represents the set of points. So what I'm going to do is I'm going to choose a point, and it doesn't matter which one I choose. I'm going to choose this one right now. And my definition says that any point on my parabola should be equidistant from the focus and the directrix. So what I'm going to do is I'm going to draw in that segment so I can visualize it for myself. And I'm going to remember that when I measure the distance from a point to a line, I have to do that on a perpendicular. Okay. Now, our definition says that these two segments should be the same. So if I take a piece of patty paper here and I measure, just kind of trace it with one, we could certainly use a ruler and actually measure its distance, but I like the patty paper. I think it's just quick. And I can see that those are in fact the same. So yes, this segment is congruent to this segment right here. Okay? Now, we can do that anywhere on the parabola and that relationship will hold true. So I can pick another point. I'm going to go ahead and pick this one. All right? Again, I'm going to draw in these two distances. And the first thing that I'm going to notice to myself is that these distances are different than these distances over here. And that's okay. What the definition tells us is that these two are equal to each other. So again, if I just trace this, so I can measure that segment out, compare it, they are in fact the same. So these two segments are congruent. And I could continue that process at any point along the parabola and that relationship would hold true. So that is our true mathematical definition for a parabola. All right. Just in summary, the big things that we want to make sure that you understand is that when we look at our equation from up above, we notice that it was the x value that was squared. And from our graph up above, we can see that it actually crosses the x-axis twice. Okay, that's good. And I touched on this in our previous notes. Then, when we change our equation around, notice coefficient and the exponent are on opposite sides, but now I'm squaring the y term, okay? That means that it's going to cross the y-axis twice. Or, in other words, it'll have the potential for it. So it will cross the y-axis twice. Remember, I could scooch it so that it doesn't actually intersect it, but what I know is that its basic shape should look something like that. And the last thing that is important is that it will not be a function anymore. Okay, it's going to fail our vertical line test. Okay, so in the rest of the notes, we're going to look at how to actually graph these and start to actually work with this new form and build on this new information that we know about it.